Inc. is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about Docker's perspectives on these timely and important topics in our latest ebook on automation and orchestration. The ebook is available for download at thenewstack.io. Hey, it's Alex Williams of the New Stack and Solomon Hykes. This interview is part of our ebook series on the Docker and container ecosystem, preparing now for the third book in our series on automation and orchestration. And I feel very lucky to talk with you, Solomon, and I'm very excited to discuss some things that may not be as literally about the technology as we normally do, but I think it'll help us expand the conversation. So how are you?
I'm great, thanks. Yeah, looking forward to the discussion.
Okay, great. Well, I had prepared something and I had sent it over to you guys before. And here's where we are, right, in my view. And I'm just really curious in your perspective on this. We're at this point where there's lots of details to application-centric architectures that are starting to surface as people explore really how to use distributed platforms. Docker has driven a lot of the new thinking about such issues as cluster management. We're entering a phase that will require, plumbing to operate without it being manually constructed. Management platforms emerge, new tools are emerging that solve some of these plumbing issues, but there are still territories that are really unexplored for the most part because we haven't yet seen a critical mass of use cases that will help the market better delineate, but we're starting to get to that point. So at this point, it seems like we're trying to understand what are the outliers versus what are the mainstream use cases. And that in many respects seems to be going to help shape what this application-centric architecture is all about. So really what I'm looking to talk with you today is about this current phase that we're in and the important drivers to consider, as this plumbing becomes more standardized and users can differentiate at the application level, really the top of the stack, so to speak. So it's just programmable because I think, as you guys have well said before, there's billions of people who are on the internet, whether they know it or not. There's going to be millions of programmers who are going to be building things for those billions of people. So really I'm looking for some perspective based on your own experiences, the work you're doing now. And that would serve to give the community some views about the ecosystem and its ongoing development. What does this mean to you right now? What is happening with this programmable infrastructure?
The starting point of all this for us is we want to democratize access to programming in general and distributed programming in particular, right? We think it's got a huge potential to unlock a lot of innovation. We think a lot of really great things will happen in society thanks to programming, and in particular, thanks to programming at the scale of the internet, because I think, and you said it just before, the internet is going through this very, very interesting upgrade where a whole lot of new equipment is coming online, and it's number one, programmable, and number two, it's networked to everything else, right? Mm-hmm. And as a result, the impact you can have by programming all this equipment, all these devices, these computers together is really multiplied. But it's only going to have an impact if we make that accessible to enough people, right? And so it's a combination of these two things: taking the programming paradigm to distributed architectures, not one computer at a time, but many. And making all of that very, very accessible. So that's our goal. In the context of doing that, so we've set out to build this platform kind of piece by piece. And Docker has a specific methodology. We're really looking to find the nuggets of technology that solve a hard problem, but still need to be democratized. And then we do our best and do that. And of course, container technology is the first nugget that we've focused on democratizing, and we've since expanded to others. And piece by piece, we're trying to build this platform that makes distributed programming more accessible. In the process, since you asked about plumbing, we've found ourselves developing a lot of small reusable components, infrastructure components, software infrastructure. And so we call those components plumbing because, you know, they're hidden, they're simple, interchangeable, you can plug them together to assemble a system, and they're not glamorous, but they're very important, and they have to be above all functional, right? What we found is that plumbing works best when you develop it in an open community as part of an open source project that is as open to the ecosystem as possible, because the more people collaborate on the plumbing, the better the plumbing is. And that's the sweet spot of open source. So along the way, as we've built this platform, we've made a big bet on an open source, and we've worked really hard to contribute our own plumbing in such a way that as many people as possible can reuse it and contribute back to it, even if it means they're going to build something other than Docker with it, maybe even a Docker competitor. And basically what we're saying is that's okay, we all benefit. Docker benefits because if you're going to build something else, something other than Docker, using the same plumbing, then the plumbing will get better in the process, therefore Docker will get better. So that's my attempt at answering your question on the role of plumbing. Docker is not plumbing, but to build Docker, you need a lot of plumbing, and we're trying to contribute as much of that as possible.
So you talk about these nuggets and really this idea of democracy, and what is it that you're seeing needs to be democratized at this point?
Well, I think a whole lot. In the grand scheme of things, programming today is still a very elite activity. I don't know if there's anyone in your immediate circle of friends and family that have come up with a cool idea for an app or a service, something that requires a fair amount of programming.
Yeah. If
they're not experienced professional programmers that have been practicing that trade for 10 years or more, right? It's very difficult. And I've been observing friends and family do that, and my conclusion is, well, as an industry, we have completely failed to make such an important medium of expression and of invention accessible to lots of people. We've completely failed. And I think I'm not the only one feeling that way, and I know there's a lot of ambitious projects, you know, to find new ways to teach coding and make coding more accessible. You know, I think it's very important, you know, and there's the need to contribute to that project of making programming more accessible. Some people are going to do it by making the teaching, improving how we teach it. Others will do it by improving the career perspectives for people who do programming, right? Our approach is to create better tools. So that's really our focus. To program, you need tools. If these tools are not designed to be accessible and useful to programmers of all levels of expertise and specialization, then as an industry, we've failed.
So in terms of this idea of failure, it does speak a lot to like the knowledge that people need to build services that doesn't require a lot of programming knowledge necessarily. I'm curious on what that, you know, what that automated environment looks like in your view.
There's two parts to that. Well, first of all, we're kind of figuring it out as we go, right? First, we're acknowledging that we don't know perfectly what's the ideal, approachable, scalable software platform looks like. You know, that is scalable enough to program many, many devices, perhaps millions at a time across the internet, while still being approachable to beginners and useful to experts. That's going to take many years to build. I don't know exactly what it looks like. In fact, fundamentally, our approach is to be incremental about it, right? It's okay for us to introduce one tool at a time and solve one small problem at a time and not try to boil the ocean, right? So I think it's very common, for example, to assume that Docker does only one very small thing, and you shouldn't use it for anything else. You should use it to run one container on one computer, and it makes that much simpler. And someone who feels that Docker, that's the extent of what Docker does, that's totally fine with us, because we solved one problem, right? We took one step towards making distributed computing more approachable. You know what I mean? The opposite approach is to try and define it all end to end, work on it 5 years in a cave somewhere, and then when it's all ready and perfect, then introduce it all at once and dazzle the whole markets with this beautiful end-to-end platform, and hope that everyone just throws away everything they have and switch wholesale to your platform. Our opinion is that that's never going to happen, and there's always someone to try that, and it always fails.
And that was an approach that we saw for many, many years, right?
And you know what? We ourselves tried it as dotCloud. I mean, dotCloud was a PaaS. What is PaaS? PaaS is an attempt to solve all the problems of development all at once with one mega platform. And, it's not working. And, that's why we pivoted away from PaaS. We concluded that certainly we couldn't do it, but we weren't seeing anyone successfully doing it either.
So how are you trying to find your way around, kind of considering this process that you're going through, where you're learning and thinking about what people are doing, and, you've solved one problem? Like, how are you following, what are the paths that you're finding from this that you're following?
Well, 3 years ago, we introduced the Docker container engine, and we've been fortunate enough to get a lot of users, a lot of people excited about Docker, who use it every day, and tell us everything about what they like and don't like about Docker. And that's a fire hose of feedback and requests and information. And our methodology is basically drink from that fire hose, see patterns emerge, and really from there, two things. One, continue improving the tools we already launched, and two, find out what's the best next tool to launch. And then over time, we've been introducing a suite of tools that you can use separately or in combination, because they're loosely coupled. And over time, we're trying to solve more and more of these problems that together form the combined problem of programming distributed applications.
Mm-hmm. What are some of those problems you're starting to see? I mean, I'm talking to a lot of people, and they're talking about, for example, like the fine-grained aspects of cluster management, right?
Yeah, that is one.
Right. How does this relate to you?
Well, if you're a developer today and you're building a distributed application,
right,
by definition, that's an application that runs across multiple computers, or will eventually, and it's architected to be broken up into multiple components, right? And we often talk about microservices as the pattern to subdivide these components, but that's what a distributed application is, right? It's multiple components running across multiple machines, and it's a way to scale the application over time, both in functionality and in usage. And so, if you're doing that, then as we found, it's very useful as a start to package up the components of your application in reusable containers. And of course, Docker helps you do that. But once you've done that, you still need to distribute and deploy these containers and orchestrate them together across multiple machines, perhaps even across multiple locations in the world, right? Again, we want to do this at the scale of the internet. And so clustering, orchestration, networking between containers, storage for across more than one container, right? That shared storage, security, things like that, verification of content, right? So that you can track the authenticity and provenance of the containers you're about to deploy. All of these are part of the problem, right, of building and deploying distributed applications. It's a big list of problems, and you need a combination of tools to address these problems, and you need those tools to integrate. They need to work together to form a platform. Otherwise, you've got a giant puzzle, and the pieces will never fit together. You'll never complete the puzzle.
It's interesting because you talk about these distributed architectures and these distributed applications across different architectures. And one of the questions I want to ask you about is that I'm a big fan of cities and love cities, and I think they're really fascinating studies for how infrastructure evolved. In Paris, where you have deep roots and where you developed dotCloud and Docker came out of that. It's one of the greatest things in the world. We're largely built on infrastructure that's hundreds of years old, but the city's adapted, right? It has its own architectural style. I'm curious on what your thoughts are about that, kind of thinking about these new layers of this architectures that are emerging, because now we're dealing with issues like how do you deal with IT policy, right? Which then forces you to kind of think about how does that impact the actual kind of application pipeline itself.
Yeah, that's actually a really good analogy, especially the concept of layers, right? The fact that infrastructure evolves over time, but really infrastructure by definition has a lot of inertia, right? Because everything else is built on top. You could look at a long list of past infrastructure projects, and if you put them in two piles, right? The pile of successful infrastructure projects and the pile of failed infrastructure projects, I think you would see a big commonality. A commonality in the successful infrastructure projects is that they take into account what came before them. They embrace the fact that it's a layer on top of something that exists, and you cannot make it go away. It's there. And just like when you're upgrading the infrastructure of a city, you can't just destroy the city and start over. You got to work with what you have. And I think all successful infrastructure upgrades do that. And I completely agree with that. And, you could look for failed infrastructure projects, and actually, Paris has a bunch of those too. If you look at, these kind of deserted, isolated suburbs with giant concrete housing buildings and nothing else for miles. And you've got people who live there in this kind of completely unrealistic environment where there is no stores, there's no jobs, because someone had a grand vision once upon a time that you could just start from an empty field and create a whole infrastructure from scratch, right? And I think that's what happens. And then from there you have urban decay and social problems and all of that. That's what happens when you're not pragmatic about infrastructure, and you just you want to ignore the past, right? You don't want to make compromises with what's there. So I think that's an important lesson. We're very serious about that with Docker. I really try hard to take that into account. It's not always easy because you have to compromise, right? And with Docker, what we've tried to do is be very clear that you don't have to throw away your existing infrastructure to use Docker. Actually, I would say that's the defining feature of Docker. It's an incremental thing to use. And we've been very clear from the start, if anyone's telling you, oh, to use Docker, you got to throw away everything you have, it's a completely radical new paradigm, then get advice from someone else, because the whole point is Docker can be used incrementally. And of course, that's a compromise for us because different people have different kinds of infrastructure. They have different habits. They have different tools and patterns. So for Docker to play nice with those and provide value incrementally is hard because we have to compromise what we believe is the ideal setup, right? I see a lot of deployments of Docker that make me think, well, I wouldn't do it that way. Mm-hmm. But I think it's a strength of Docker that it allows for that. And I think it's a big misunderstanding, honestly, because Docker gets criticized a lot. I think it's fine. Anything of significance will get criticized. Right. A lot of the criticism is anchored in, pointing at a particular use case of Docker and pointing out all the areas where it's not, it's not best practices. For example, Docker has a concept of Docker file, right? That helps developers specify how to build the container from source, and it's a very simple way to take a build specification that's kind of hidden across a lot of custom scripts and just put them in a place that's standardized. And what happens is when developers take their existing build methodology and they just put it in that Docker file for everyone to see and manage, that puts a spotlight on all the rough edges, all the shortcuts, right? You have parts of the build that are not repeatable. You have sometimes parts of the build that are not secure. And that's just the reality of development, right? But guess what? You can use Docker without being a perfect developer. In fact, Docker maybe can help you over time improve your best practices. But, that's the compromise. As a result, you can use Docker and do dumb things. And sometimes Docker gets blamed for that. Overall, I think it's a net positive for the industry because over time, we're moving the needle on best practices. We're improving the average development and deployment setup.
A lot of it does come down to having the pieces almost built for the developers, so they're not mucking things up necessarily, or not that you don't want to ban them from doing those kinds of things, but a lot of developers, like anyone, when I walk in the house, I want the floor to be able to support me, right?
Right. Yeah, but I agree, and I used the word layer earlier. I think layers are the key. If you walk into a house, then you want the floor to support you, and because that seems like a legitimate requirement to me. I would agree with that requirement. And you know what? Let's go crazy and add the roof should not collapse on me either. Because of that, there's rules for what house builders are legally allowed to ship, right? But note that that's those rules and the best practices for professional home builders to follow these rules, and architects, etc. These are layered on top of the tools to build houses. So you can still buy a hammer and a saw and a bunch of planks, and the hammer it's not the job of the hammer to somehow prevent you from building a really unsafe house, right? In fact, it would be a waste of effort to try and make a hammer that is impossible to use unsafely,
Right.
So I think the key is to differentiate what is a hammer and what is a permit to build a house, right? I think it's similar in building software. The Docker plumbing would be the equivalent of the hammer and the saw, right? We provide all these fundamental tools you can use in a lot of different ways. And then we combine them in a sort of a kit, that's what we call the platform, that gives you all the tools properly arranged and everything you might need to build your own house. And, it includes a lot of helpers and documentation and examples to help you build a good house. But, maybe you want to build something else and we're not going to prevent you from it. But then on top of that, if you're an organization, if you're a business and you're in the business of, building large, reliable houses, then that platform is a starting point, but you need more, right? And you need maybe an auditing tool, right? Maybe you need a whole collection of services to make sure that what you ship at the end is up to your standards of quality, right? If you're building a skyscraper, then you're going to need even more help, right? And that's where, our approach to that is if you're a business, if you're an organization and you have business critical requirements, then that's where you should find a vendor that you trust and buy services and products from them. And Docker, the company, sells products to help organizations build business critical software and deploy it in a reliable, secure way. But there are other vendors out there that can sell you competing products. And, all of these products are layered on top of the Docker platform.
Right. It's an interesting conversation. I recently went to Palm Springs. Have you ever been there?
No, but I know where it is. I flew over it. It's easy to spot from a plane. That much I know.
Well, one thing I really find interesting about Palm Springs, I never been there, is there's this real mid-century architectural style there. It's an interesting kind of study of how architects of the post-war era and came there and essentially developed these homes that were more lightweight in design and style. And those homes became the foundation for a lot of modern architectural styles that you see, right? Like ranch houses, and which are very kind of like big rooms, there's bigger kitchen spaces, all those kinds of things. The styles that preceded that in many were like the Craftsman style. Then you had like the like the Victorian style, and they can create that. And it was, but the mid-century style was really much more different. It was much more lightweight. It seems like we're in a similar place. We're going to really require these applications to be architected in much different ways. But that's interesting to me because in the world that you're a part of, you have these distributed architectures, but there's this kind of immutable nature to the architectures themselves. I'm just curious how you balance this whole new generation of applications that we're going to see.
Yeah, I really can't shake off that analogy of the city that you're using. I think it's a perfect analogy because, you can remodel a house, but, mostly once you've built a house, that's the architecture of the house. It's very rare for a house to convert from one style to a radically different style, right? And I think it's same for programming, right? When you write a library or a particular software component, it's very rare that it's going to be destroyed and rebuilt in a completely different style or architecture. Rewriting from scratch, destroying something and rewriting from scratch in another language rarely succeeds. And even if you're going to do that, in practice, what happens is you're going to keep the existing house, then you're going to kind of build the version 2 house next to it, and then you're going to have this awkward phase where they will both coexist somehow, and then you'll try and deconstruct the first house so as to not disrupt the flow of people, right? It's very hard. So the right model, I think, is to think of your overall software stack, whether you're a company or, if you're an organization that builds software, you never have only one house. You got a bunch of components, a bunch of applications. There will be new ones over time. You will renovate some of them. You will deprecate older components over time, right? And really, it's the entire city that matters. If you're a small company, it's a little village. If you're a multi-billion-dollar corporation, it's a whole city. But I think that's the right model. And so the house mostly is immutable, or at least there are a lot of constraints to changing it. But the city is very mutable, right? Because you can add and remove a lot of these immutable houses.
Right.
So that's what we're most interested in. What the Docker platform aspires to do is provide a framework to build and develop your entire city. And that's really what Docker is good at, because it's good at finding a common framework to components that often are very different. And that's why, again, we emphasize so much the fact that you can use Docker to manage your existing city. Docker will adapt to what you already have, right? And that's crucial because otherwise no one wants to start over. So we really think of it in that way. And yes, at any given time, there are known best practices for architecture and urban planning, right? As a society, we learn lessons in the past of what works and what doesn't work for building cities and houses, right? And so, in general, everyone building one of these cities is going in a direction of improvement and progress, right? So there is this kind of ideal state where your city is just the best it can be. What matters is that you're aiming for it and you're making progress towards it, but you're never going to be done improving your city, right? So, that's a very different approach, because if you come in saying, okay, at no moment will there be a single earth-shattering switch where on Monday I have the old, ugly legacy architecture, and on Tuesday my whole enterprise is now upgraded to the magical architecture, and all my problems are solved. Right? That pattern is, I would say, the #1 source of failed IT projects in the world. If you assume that magical one-time switch will never come, then I think you've just dodged the biggest danger for your enterprise IT roadmap. Now you can focus on pragmatic incremental changes, and we Docker want to help these software city planners to plan the improvement of their architecture as efficiently as possible, but on their terms.
So this leads me to the last question that I have, and I think this sets it up very well, what you said. And kind of going back to this architecture and urban planning discussion, one of the things you did see, out of that mid-century architectural style was kind of like this convergence of other factors. So you had not just the capability of building these very, lightweight homes, but they were also less expensive to build. And you could build a lot of them. And there was a big demand for these homes.
Mm-hmm.
Today now, what you guys are symbolic of, and many, and core to, is this idea of these new sets of economic drivers that clearly are transforming the application ecosystem. So particularly we see the impact of open source and its role in driving development. So I'm just really curious on your view on how these open source ecosystems will evolve and how you'll fit into that evolution as these economic considerations become fundamental to the overall, thinking and building out of these distributed infrastructures. And
I mean, you're right. There's a really big change there. There's a big trend. I think it's a multi-decade trend. It's bigger than any individual company. It's certainly bigger than Docker. I like to think we're part of it. Maybe even accelerated it, enabled it in some way. But I think it's even bigger than the tech industry as we typically define it. Right. Mm-hmm. This is really it's a shift in how we do commerce. I think how we create products and distribute them. And it's driven by the fact that a lot of it now is anchored in software, right? Almost any organization in the next decade or so will have software and programming at the heart of what they do, one way or the other, right? And there's this famous motto, "Software is eating the world," and that I think that really captures it. But I think it's just the beginning of that. And with that comes, for all of these organizations, the question of their supply chain. And that's really the central question. If you're an organization, you have some sort of a supply chain. You have suppliers and you consume goods, equipment, services from them, and then you in turn provide goods, equipment, services to your customers, right? And a lot of these companies that are used to a supply chain that is not really software oriented now have to adapt to the fact that soon their supply chain will be a software supply chain. There will be an important software element to their supply chain. And now everyone's scrambling to figure out what that means. How do I compete with the software supply chain? Mm-hmm. That's really it, right? And that's where the shipping container analogy really shines, because the physical shipping containers, really enabled a complete revolution of the physical supply chain of almost every company in the world, right?
Yeah.
Because now a lot of the stuff that comes in your company, a lot of stuff that comes out, it circulates and it's managed through shipping containers, and the worldwide system that moves them around, stores them, identifies them, etc. And now we're seeing software containers start the same trend. So that's the big question. How do I run competitive and agile and stay in control of my software supply chain? Everyone's trying to scramble to get an answer. Everyone knows the answer has something to do with producing cheaper, more reusable, more agile components. It has to do with, adapting to change faster than your competition, right? Moving into a promising new market faster. And it's the same thing played out in the physical world, right? Toyota and the Japanese company manufacturers were famous for having a really well-run supply chain that made them incredibly agile and allowed them to outmaneuver their competitors, right? Because they were in control of their supply chain. They considered it a strategic asset. This is exactly the same, but in software, right?
How do your views on open source fit into this, and and your views on Docker overall?
Open source is the extreme manifestation of this trend. I think in the same way that once the physical supply chain was made, what's the word I'm looking for? Was democratized. Was made efficient enough, scalable enough that you could ship a few tons of physical stuff halfway across the world in a very cheap, efficient, approachable way. That made global shipping much more accessible to much smaller groups of people, right? Fast forward to now, it made companies like Amazon possible, right? But also allowed, it makes it possible for, two people in the garage to make some cool object and ship it halfway across the world, right? I got a friend who just finished a comic book. She's got a whole community of followers on her blog. She did a Kickstarter for the paper edition, so she's self-published, and she's shipping all the books to her readers all across the world herself, right? And it's economical for her to do that because of this underlying infrastructure based on shipping containers, right? So I think open source is kind of the equivalent of that, except even more extreme because it's software, right? The cost of production is even lower. So it's not even one person in a garage doing a side business. It can be, one person 2 hours in the evening just coding something they like and distributing it to the rest of the world, right? The economics support software to be given away for free, and in some cases, right? So the question is, how will open source fit in this new software supply chain, right? I think there's a lot of open questions. Like we haven't solved the problem of how to support people who write open source code, right? That's an unsolved problem. And you've heard about this, right? But the authors of OpenSSL, which is a crucial open source component, it's really a key part of the infrastructure of the internet, lacked the funding to properly maintain and upgrade their libraries, because it's an open source project, and there's no single company has a big interest in investing lots of engineers into it. So there are stopgaps, there are foundations, there is initiatives to donate money, but honestly, the economics of open source have not been figured out, right?
And that's a question for another day.
Yeah.
Very, very interesting one for us at the New Stack, and we look forward to talking about it more with you.
I would be happy to.
Great, that'd be fantastic. We're looking much more deeply into that. But I want to thank you very much for taking the time to talk with me today.
Thank you. Yeah, great conversation as always.
Yeah, I really enjoyed it. So thank you, and I'm sure our paths will cross again soon. And someday, hopefully, we'll get the chance to walk around Paris and look at the architecture.
I would love that. Yeah, let's do it. We can go to the catacombs.
Yeah, that'll be fun. Okay, well, take care of yourself, and we'll talk soon.
All right, take care. Thanks.